Hello everyone and welcome to a new video in Python. In the previous video we talked about primary data types, integers, decimal numbers or floating point numbers, and we talked about strings. In this video we will talk about two other types of data types, Booleans, the Boolean variables, and lists. First of all, I would like for you to launch Jupyter Qt Console. This is one of the products that came with Anaconda when we installed it in the beginning. If you don't have Anaconda, just open a kernel of whichever distribution you're using. To clear the entire screen and get rid of all of this, you can either type clear or Control L. A Boolean variable or a statement is something that can be true or false. So let's define our first Boolean variable. A equals true. Notice the T has to be capital. So if you do type A, let's say bool for Boolean. Boolean variables are usually used for comparison rather than saying A is true. Something like A equals, say, 5 less than 7, and if you print A, we get true. Here is a list of comparison symbols that can be used. We have less than or equal. That's how we use that. Greater than or equal, is equal to, so two equal signs next to each other, not equal to, exclamation, and an equal sign. So let's look at some examples with these symbols. 4 is equal to 5, false. 6 is not equal to 4, it's true. 7 is greater than or equal to 7, and so on. These will become very handy when we introduce the if statements in the for loops. I would like to also introduce the and, or, and not logical arguments. So let's say here 1 less than 5, and so you can see it's colored, so it's one of the recognized keywords. And let's say 3 greater than 10. So here's how Python will interpret this. So 1 less than 5, that's true, and 3 greater than 10, that's false. So true and false is false. Now let's use or. So we do the same thing. Say or. We can see it's true now, true or false. One of the two statements is true, so automatically it's true. We can use the not command. So up arrow to recall that. Let's say not. So not 1 less than 5, so that's false. Or 3 greater than 10, false. Both statements are false. False or false is also false. Now let's talk about lists. First of all, clear the screen, Control L. And let's define the first list. Let's say L equals bracket. And a list is a sequence of objects. They don't have to be all numbers. So let's say here. Now we look at the type. It's a list. You can call element by element right here. Notice it. L1 is 5, as I indicated before. The first element here is 0, right? So out of range. Maximum we can use is 3. That will give us the last element. It's got 4 elements: 0, 1, 2, 3. Alright, so now let's define two lists. Let's say list A with, say, 1, 2, 3, and variable B. So what do we get if we do A plus B? So there's its concatenation. Gets A and B concatenated. So what's going to happen if we, let's say, multiply A by 3? Let's see. List A time. We can see the list is repeated 3 times, right? One way to create lists in Python is using the range command, which is pretty common in Python. Let's print C. We can see that C starts at 0, ends at 4. So think of this as being starting at 0 and then with the 5 elements. So the number 5 itself is not included. So that's one version. Another version for that, let's say D range starting, let's say, at 2 and let's see, ending at 7 here, but not including 7. So we can see here that it starts at 2, so it's inclusive of 2 and exclusive of 7, all the way up to 7, not including 7. The third version of the range command is if you include a step to your argument here, a third argument, let's say step 2. So D, get 2, 4, and 6. You start at 2 and then step 2 all the way to 7, not including 7. Okay, now to slicing. Slicing works with lists just like it does with strings when we covered it in the previous video. So let me clear the screen first and we call D. So this is the list D. So we could do D. You may recall this from here. It starts from the first elements because we're leaving this blank, and it goes up to 3 elements, right? We can also do negative indexing with lists. So here, say 3 to -1. So all the elements except the last one, just like we did with strings. Here's another example. And you can see we got the 2 elements 4 and 5. We can change the value of a list, something we couldn't do with strings. Let's say, right, D1, that's the item number 3 right here. What if we want to redefine that to be, let's say, 7? Now, print D again, and you can see the second element is 7 right now. We can change multiple elements at a time. Now print D, and we can see that the first and second element that are included here in this slice, 2 elements, are replaced by 10 and 11. The number of elements we're adding here does not have to be 2, so we could add, let's say, 13, 14, and 15. Print D. We can use the length command to find the length of a list, just like with strings. There's 8 elements. We can also test if an element is in the list or not. Let's say here's D. We want to say, let's say 12 in D, false. The item 12 is not in there. How about 5 in D, be true. How about 11 not in D, we get false, right? This will be helpful when we deal with if statements and loops. We can have a list of lists. Let's see how this works. So let's define, say, a new list, G equals. Yes. Now, how many items? If we do length of G, we get 2 elements, right? The first element is a list in its own right. The same thing for the second element. So if you do G1, you get the item, the first with index 1, which is the list 4, 5, 6. If you want to call an item within the list 4, 5, 6, you can go double indexing 1, and then let's say you want to get the number 5. Get that. Now let's look at the methods that go with lists. Clear all this. So we have the D here. If you put D dot and then tab, it will show you the methods that go with the list. So append, straightforward, and let's print D, and you can see the element 2 is been appended to the at the end of the list. If you do D.C and then tab, we get D count, and then parentheses. Let's say we want to count how many 2's in the list, and we have 2 2's, 1 in the beginning and 1 in the end. Alright, now let's try the Deduct Pop command. Here's D again. D.Pop. Let's say 2. It will remove the element with index 2, so 0, 1, 2, basically 11. And it says 11, print D again, and again 11 has been removed. The pop method removes the element with index 2. The remove, however, let's see what to do. If you do remove, let's say 13, the element itself, and then print D, it removed element number 13. So it really removed the physical element 13 versus the element with index number 2 in the pop command. You can sort the elements of a list, d.sort, and print d, and it's been sorted in ascending order. We can do d.sort, and then reverse equals true, and we can see it's in descending order. Feel free to try the other methods, d.tab, see the ones we did not try and try them. Even the ones we tried, gonna try to mess around with them, like sort. Once you open parentheses, it's going to show you some options here. That's the reverse equal false, that's the default. So ascending order, when you put it true, it becomes descending order. So try the other commands and see what you get. It always helps to learn by practice. This is the end of this video for today. I hope you're enjoying learning Python. So far we learned to define variables. We learned 5 different types of data types: integers, floats, lists, booleans, and strings. In the next video, we will talk about if statements. And actually, in a following video, we'll also talk about for and while loops. Once we have these added to our skills, we will be able to write an entire code, a block of code, to run a program or to execute a command. Much more what we have been doing so far. Until then, thanks for watching, and see you next time.